Hey everybody, welcome back to Mr. A's geometry course. Today we're going over our last lesson of Unit 3, which is all about the equations of perpendicular lines. Let's get into it. So again, we're going to be writing equations of lines in slope-intercept form, y equals mx plus b. And the key to this is understanding and memorizing that perpendicular lines have what's called negative reciprocal slopes. Negative reciprocal slopes. And you can find a negative reciprocal of a fraction by flipping the fraction, so you're exchanging the numerator and the denominator, and then changing the sign. So if you originally have a positive fraction, the negative reciprocal will become negative. If you originally have a negative fraction, negative reciprocal will become a positive, right? For example, the fraction 3/4, the negative reciprocal of it would be negative 4/3. So it goes from positive to negative, I change the sign, and then I flip the numerator and denominator. So this occurs, remember, for all perpendicular lines. They have these negative reciprocal slopes. So our first skill is going to be identifying negative reciprocal slopes. So I have a bunch of values up here that could all represent the slope of any line. If we're going to write the equation of a line perpendicular to it, we would then need the negative reciprocal of all of these slopes. So for positive 3/8, we're going to flip the fraction, so it would become 8/3. And since that is a positive fraction, we would change the sign and make it negative. For the slope of negative 2/7, we would, again, flip the fraction first. So we have 2 on top, 7 on the bottom. We're going to flip that for 7 on top, 2 on the bottom. And this slope is negative, so the negative reciprocal would have a changed sign. It would be positive 2/7. I'm going to do this just to kind of separate our answers here. Our next slope is positive 1/3. So again, we are going to flip that. So we're going to end up with 3/1, and we're going to go from positive to a changed sign, which would make it negative. Okay, and then here's an important thing. We will oftentimes get negative reciprocals that, even though they're written as fractions, can also just be whole numbers. So negative 3 divided by 1, we could also just write that as negative 3. Okay. Next, we have the whole number negative 4, which we want to first change into a fraction so that we can do the flipped part of it. And hopefully you guys know that to make a whole number a fraction, you just put it over 1. So negative 4 as a fraction is just negative 4/1. And again, we're going to flip that. So it's going to become 1/4. And we're going to change the sign. So this is a negative value here. It's going to be a positive value in the negative reciprocal. So positive 1/4 would be that one. All right. The next one's a little tricky. 0/8. Okay. Flip first. 8/0. Sign change is positive here, so it's going to be negative over here. But we need to be careful because if we divide a number by 0, there's a very specific result to that scenario. Now, 0 divided by a number, like here, would always give us the value of 0. It wouldn't matter what number is on the bottom here. When we divide a number by 0, though, it breaks the world. It's not a thing. It can't happen. And so we really wouldn't write negative 8/0 here as this. We would just call this undefined, because we can't define what happens when we divide something by 0, because it's not possible to do that, right? So undefined and 0 are negative reciprocals of each other. And our last one, we have value of positive 9, which again, to turn that into a fraction, I just put it over 1. Then we flip those, so it becomes 1/9, and we had a positive value here, so the negative reciprocal would be negative value. So negative 1/9. This is how we find negative reciprocals. So now that we know that perpendicular lines have negative reciprocal slopes and we're able to find the negative reciprocal of any given value, we are going to identify perpendicular lines. So we have 4 equations here that all have slopes. We're going to evaluate all of their slopes and determine if any of them are negative reciprocals of each other, therefore making them perpendicular. So first we need to find the slope of all these lines, which, remember, is just the value in front of your x. So I have y equals 1/3 x minus 9. The slope for that line was just 1/3. The slope for this line, we have 7/8 x. So our slope is 7/8. The slope for this line is -3. the slope for this line is positive 3. Now, one thing I want us to do before we start thinking about which of these could be negative reciprocals of each other is to take the whole numbers and turn them into fractions, right? So remember, negative 3, I could make that negative 3 over 1 as a fraction. Positive 3, I can make that positive 3 over 1. And again, now we're just evaluating which of these is negative reciprocals of each other. Well, we can rule out the 7/8 because there's no other slope that involves a 7 and an 8. The rest of our slopes have a 3 and our 1, so we're just looking, do any of these have a flipped fraction and a changed sign, right? For example, we have a positive 1/3 here. Both of these have it flipped where a 3 is on top and a 1 is on the bottom. But remember, what makes it the negative reciprocal is the sign change. So this one was positive, this one is negative. So here's where we had a sign change and a flip of our numerator and denominator. Those would be the perpendicular lines in this example. 1/3 x minus 9 and negative 3x minus 2. We're gonna take all this perpendicular line knowledge now to actually write the equations of perpendicular lines in slope-intercept form. So we're writing the equation of a line perpendicular to y equals 5x minus 2 and containing that point positive 10, negative 4. So the perpendicular part in here is important. We know perpendicular lines have negative reciprocal slopes. So we're going to find the slope of the line that we're perpendicular to, and we're going to write the negative reciprocal of that, and that will be the slope that we're going to use throughout our problem. So our line is y equals 5x minus 2. We can determine that the slope of that line is 5, but again, we need to recall that perpendicular lines have negative reciprocal slopes. So I need the negative reciprocal of 5. Remember, 5 as a fraction would be 5 over 1. The negative reciprocal would require us to flip that. So we get 1 over 5 and to change the sign. So we're going from positive to negative. That now is the slope that we're going to use in y equals mx plus b to write our equation. So we're using that. Remember, we're using our x and our y from that given point that's on our line, and we're plugging that into our slope-intercept equation. So y equals mx plus b. We're substituting our y for the given y-coordinate of negative 4. We're substituting our m for the slope that we know we need. That perpendicular slope is negative 1 over 5. We're substituting our x for our given x-coordinate, which is positive 10. And the only unknown is that y-intercept that we need to solve for. So remember, from here we're multiplying by these fractions. We're doing negative 1/5 times 10. And the way that we can do that is take our whole number value, multiply it by the numerator, and then divide by the denominator. So 10 times 1 divided by 5 is 2, and it's a positive 10 times a negative 1/5, so that would end up being a negative 2 here. Now I can get that b alone by using my addition property of equality, adding 2 to both sides. I get a y-intercept of negative 2. And so the equation of my line perpendicular to this one would be y equals negative 1/5 x, because again, I need the perpendicular slope. My y-intercept was minus 2. Guys, in this example, it is just a coincidence that our y-intercepts are the same value. It is not the case for every equation. Let's see if you can do this one on your own. We're going to write the equation perpendicular to y equals negative 1/4 x plus 7. So let's find the slope, determine what its negative reciprocal is for the perpendicular line, then use that slope in this point to write that y equals mx plus b equation in this example. Again, pause the video, see if you can do that on your own. Okay, let's see how you did here. Again, we're going to determine the slope of our given line first, which is that value in front of x. In this case, it's negative 1/4. And we know our perpendicular line will need the negative reciprocal of that value. So we're going to go from negative to positive. We're going to flip our fraction. So that's going to become 4 over 1, which we can just simplify as positive 4 for our work involved here. We have an x-coordinate of negative 1, a y-coordinate of positive 3, and we're going to plug those into our slope-intercept equation here. So we're substituting that into y equals mx plus b to solve for the y-intercept, the b. All right, so substituting my 3 for my y, gives me 3 on the left. My slope I know needs to be 4, that's my m. My x given to me is negative 1. right? We have that plus b, right? 4 times negative 1 gives me negative 4. And now I can get my y-intercept alone by using the addition property of equality, adding 4 to both sides, and I get a y-intercept of positive 7. So the perpendicular line will have that negative reciprocal slope of positive 4, so 4x. And then we get a y-intercept of positive 7, which again, just coincidence that that has happened here. I'll make sure I change that in the future. Just a coincidence that we got the same y-intercept. This does not happen often for our perpendicular lines. In our last example here, we're going to be taking a standard form equation of a line and figuring out the equation that is perpendicular to it. So remember, what we have to do in this scenario is convert our standard form first to slope-intercept form, right? So we have negative 3x plus 4y equals 2. To convert that to slope-intercept form, we just solve for y. So we need the y alone on the left side of the equal sign. So I'm going to move this 3x to the right by adding 3x to both sides. That leaves me with a 4y on the left equal to a 3x plus 2 on the right. And now to get y alone, I'm dividing both sides by 4. Cancels the 4's on the left and gives me y equals 3/4 x plus 2/4 or 1/2. You can write 0.5, it doesn't matter there. Remember, the key is understanding what the slope of this line is. That's why we convert it to slope-intercept form. We can now determine that the slope here is 3/4 for our given line. And because we're writing the equation of a line perpendicular to this, we need the negative reciprocal of that for my perpendicular slope. So flipping, 4 is going to go on top now, 3 on the bottom, and changing the sign. We started with a positive slope, now it's negative. It's negative slope of 4/3. We're using that in this given point, -6, +1, to solve for the y-intercept of our line. All right, so we're putting all of that into play now. Instead of y equals mx plus b, we're substituting in our known values. Again, our y coordinate was 1. We know our slope needed for this is going to be -4/3. Our x coordinate was -6. Now we can solve for b, the only remaining unknown in this equation. So multiplying -6 times -4/3. First, negative times a negative is going to give us a positive. And remember, we're going to do 6 times 4, which is 24, divided by 3, and we get 8. So we have 8 here. And to get the y-intercept alone, now I'm going to subtract both sides by 8. My y-intercept is -7. Again, here's the proof that your y-intercepts are not going to be the same, right? It's just a coincidence for our previous example. So writing my equation of my line, y equals, with our perpendicular slope, -4/3 x. We just found out our y-intercept was -7. That's our perpendicular line. And guys, this wraps up our lesson on the equations of perpendicular lines. And this is the last lesson of Unit 3. Only thing to do now is study. Get ready for our unit assessment. I'll see you guys in the next unit. Bye, guys.